All right, so it's been a while since we were in the classroom together. Before spring break, we were over in the library for that presentation from Dr. Zatar, and I thought that was an interesting presentation because the first half of it, he was talking a lot about infrastructure, inventory management, you know, the notion of when you've got limited funds to repair bridges and roads and other things, how do you allocate that money and do the maximum benefit? So I thought it maybe tied in nicely to some of the capital rationing that we're going to be talking about as early as today. You've got 2 homework assignments that you've submitted that aren't graded yet. And I'm going to grade those tomorrow so that you get some feedback on those assignments before the exam on Thursday. To prepare for the exam on Thursday, besides the article that I've given you, you should prepare an equation sheet. I'm going to provide you with the same time value of money formulas, you know, find F given A, find A given P, those formulas. I'll give you that. I'll give you any factor tables that I want you to use. But then you need to be prepared to do the rest. So the types of questions that you should focus on is basically what we've covered since the first midterm. So the coverage on the exam, if I go to our schedule for the semester, let's take a look at that quickly just to review the range of topics. Okay, here's our schedule. So midterm exam 1 we had back in February, and since then we've talked about bonds, external rate of return, incremental rate of return, benefit cost, incremental benefit cost, and then today we're going to do cost effectiveness analysis and economic service life. So all of those topics are included on the exam. So you should include the bond investment formula. You know the formula for finding the value of the bond? Put that on your equation sheet. Maybe you'll want to put a little reminder on how to do an external rate of return analysis, because that's a spreadsheet problem, but you need to begin your exam problem with a blank workbook. You can't use your homework. You can't use the pre-provided template files that I've given you for in-class exercises. You need to demonstrate that you're not just plugging numbers into something that I gave you, but you understand the concept well enough that you can create a spreadsheet from scratch and solve an external rate of return type problem. Or in the case of incremental rate of return, maybe on your equation sheet, remind yourself what's the step-by-step procedure. Remember in the incremental rate of return how if we're doing the increment, you start with the cheapest alternative and compare it to the next most expensive alternative. It would be really valuable practice if you go back through the in-class exercises that are associated with each of these class meetings. And there's videos posted on YouTube if you need a refresher on how to go through the spreadsheet. For each one of the in-class exercises, I had the recording going when I was doing the solution for that day's in-class exercise. So just to recap, you can bring a page of notes front and back, and it should have formulas and also procedures so that you're able to do each of these kinds of analysis starting with a blank workbook. So any questions about the exam? Yeah.
Can you upload the notes from lecture, I guess, 12 to 17 or 18 to Blackboard?
Yeah, we'll do that.
Thank you.
Mm-hmm. All right. Any other questions? All right. I've emailed you a link to a podcast, and it's also posted on Blackboard. And you should listen to that podcast after the exam. You don't need to do it before the exam, but before class on Tuesday, because on Tuesday of next week, I'm going to give you the next project. We've only got 2 homework assignments and 1 project left in the class as far as things for you to work on. Of course, there's exam 2 and the final exam, so 2 exams, 2 homeworks, and the project. So I'm going to assign the project on Tuesday of next week, and that podcast is important to help you understand the discussion about the project. It'll kind of give you the vision for what we're doing in the project. Okay, any questions before we start talking about cost effectiveness analysis? Okay, well, this is a picture of an automated traffic control sensor, the kind of thing where they've got the cameras to trigger the intersections, you know, to help know, like if there's a vehicle waiting in the detection zone, it will let the timing system know when someone's waiting, so it would then trigger a movement in the opposite direction. But these cameras can also be used for giving tickets to people who run through intersections. And the laws vary from state to state on whether they can be used in that way. But there are some places where cameras are used for speeding or they're used for intersection control. And the reason I mention it is that sometimes it's difficult to quantify the benefit when it's a non-economic advantage of something happening. So if you think about, if you pay the money to install a camera system like this, the benefits would be maybe the more efficient management of traffic. It would be maybe that people are less likely to run through the intersections, and that's probably going to mean that there are fewer collisions and maybe less ambulance calls and less medical bills, and all of those things obviously have financial consequences, but sometimes it's difficult to assign a dollar value to the benefit. And if you think about the tools that we've used so far to evaluate nonprofit projects, it's just benefit cost analysis. And in benefit cost analysis, what we had to do is we had to somehow translate everything into dollars. You know, like if you go fishing, what's the dollar value of that recreational opportunity? Or what's the dollar cost of some additional noise during construction? And sometimes it's possible to do that, to translate things into dollars, and sometimes it's really either not possible or it's just our accuracy is really poor, and so we want to have other tools for comparing things besides having to translate them into dollars. And what we're going to do today, this cost effectiveness analysis, tackles those kinds of questions of, you know, how can we pick alternatives when we don't necessarily want to monetize the benefits. So it's often applied in service sector projects where we're operating some service. It's not necessarily generating a physical good, and so therefore the service may not have a value where people are paying for necessarily what it's worth. So it's an intangible. There's service sector projects and healthcare, accounting, the police, and so just as an illustration, when you go to the hospital, you pay a fee for your services, but the value that you get of that service is maybe much greater than the fee that you've paid. And so let me give you an example. If you go to the hospital and you get vaccinated for polio, you know, you may only pay $2 or $3 for that polio vaccine, but it doesn't mean that the polio vaccine is only worth $2 or $3. The benefit of that vaccine could be potentially tens of thousands of dollars if you avoid a contagious disease that would have devastating consequences. So service sector projects like this, a lot of these things provide benefits that are different from their cost of operation, like the police. If you think about what's the value of having law enforcement, it helps to maintain an orderly society. You're less likely to be injured or murdered or have your property stolen. And so the value of having the police, having someone out there enforcing the law, there's value there, but the service is difficult to put a dollar value on without a lot of like assumptions and extrapolation. So sometimes we just say, let's dispense with all that and use some other method of assessing and comparing alternatives. So if it's difficult to estimate the benefits, then instead what we'll do is come up with a ratio of the costs to some other measure of effectiveness besides the value of the benefits. And so we're not saying the dollar value of the benefits, but here we are expressing the costs in terms of their dollar expense. So all of these things, it's relatively easy to know how much it costs to provide the service in economic terms, because you're paying people's salary or for the equipment, whatever the underlying cost is, that's easy to know in a quantitative way. But the effectiveness is just measured some other way. So as an illustration, let's say that we had 4 different offices that are each processing passport applications. And so it could be that there's an office in New Orleans and Washington, D.C., one in San Francisco, and one in Fargo, North Dakota. And those 4 offices are all processing applications, and they have different operational costs because maybe the real estate is expensive in D.C., but it's cheap in Fargo. Maybe the utilities are expensive in Fargo, but less expensive in New Orleans. And so each of them have their unique characteristics that could be expressed in terms of the operation costs, like how many dollars per hour does it take to have this office open. And we also have data, in this case, for how many applications per month are being reviewed and processed at each of these different offices. So where this is headed is we're going to estimate for each one of them their productivity. On a per dollar basis, how many applications are they processing per dollar? Okay, so our procedure in a case like this is we calculate cost to effectiveness, some sort of a ratio. And so it doesn't necessarily have to have units that make sense. Like in this case, I think what we've done is we've just divided the costs per hour by the applications processed per month. And so the time units there are inconsistent, which is okay, but because each of them have the same units, all we're really trying to do is minimize the cost per efficiency. So you'd want to have the most applications processed and the least amount of dollars. So you want this C to E ratio to be as small as possible because you want a small c and a big E. So we could have calculated dollars per application if we knew how many hours per month the office is open, but we don't know that. We're not given that data, but we don't necessarily need it because we just are assuming that they're all open the same number of hours per month, and so we calculate some measure of C to E. Now here's where things get a little bit less basic, because so far this is easy. Now in the next step we reorder it, and we put the most efficient at the top. So if you look, which of these offices is the most efficient? They have the lowest cost and the highest productivity. B is the best because it's got the lowest cost to efficiency ratio. So we reorganize this with B at the top and D at the bottom. So D is the worst because it has, relative to the number of applications being processed, it has relatively high operational costs. Now, so column 4 is the same data as we had before, just reorganized. And now column 5 is the cumulative cost in terms of dollars per hour. So 450 is just if we only have Office B operating, then it's $450 per hour. Now if we have A and B operating, then it's 450 plus 875 if we have both of those 2 offices operating. So then the total cumulative cost for having both offices open is $1325. If we add Office C, you can see that the cost goes up to $2425. If we add Office D, then the cumulative cost for having all 4 of the offices in operation is $3,075. So here is a budget limitation, $1,600 per hour. So we've got a budget limit. So which offices should we have open if we can only spend $1,600 an hour? Well, in that case, if our limit is $1,600, then we can open B and A. And we'll maximize the number of applications that are processed if we have B and A open. And if partial spending is allowed, we could take some of the leftover money and put it into Office C, like if they could do partial staffing. But B is the most efficient, so you prioritize them first. They have the lowest cost, the most effectiveness. So does that make sense to everybody? Any questions? So that's all this process is about, is trying to figure out, when you've got capital rationing that applies, a limit on how much you can spend per hour, per month, or whatever, per year, then you're trying to find out which of the options should be funded. Because there's always people who will take your money and they'll do something with it. But you want to get the maximum effect for the dollars that you spend. So we're going to try practicing this with an in-class exercise. And let me give you the handout. Okay, so this is similar to the example I was showing, except for this time we're going to make the units a little bit more meaningful. So you'll notice that there's some blanks in the table. I'd like you to calculate the total cost, because what we're given is for each of these different non-governmental organizations, there's 1, 2, 3, 4, 5 of them, how many people they have on staff, and how much they what is their cost per person on the staff. So obviously total cost is just going to be personnel multiplied by cost per person. And then the cost effectiveness ratio will be number of dollars, so the budget, divided by the poachers arrested. So you're going to do the similar thing that we did before, and then reorganize. And you can do this on Excel, by the way, if you'd like, but you don't necessarily have to. But what we want to know is, if you've got $5 million as a budget, then which of these organizations can be funded and which ones should be funded to maximize the number of poachers. Now we assume no partial funding. So you can't do that thing where you take some of the leftover money and put it in the one that just barely misses the cut. Just only assume fully funded organizations. And then part D, we want to know how many poachers per year are going to be arrested if we have those particular organizations that are funded. So you can do this one on Excel if you like. Otherwise, doing it by hand is also okay, but maybe it'll take a little bit longer. Let me just show you one function when it comes to determining the cumulative amount. So remember that the cumulative amount is basically the cost of, for whatever row you're on, operating that organization and all the ones above it. So right now on row C, it's just only that organization, so it's the total cost of the single group. But now in this row, it would be the total cost of both C and A. So we could do it this way. We could do equals this cost plus that cost. So that works. Or what we can do is we can say it's the previous cumulative amount plus the cumulative amount of the row that we're on. And the advantage of doing it that way is that then you can drag it down and it will find the cumulative amount for all of the organizations. So for example, if you are saying this row, it would be the sum of all of the the four organizations. So you can see down here at the bottom it says the sum is 6,074,000. That's the same as we got here. So it's kind of just looking at the cell above plus this one over here to the left for the total cost of that organization by itself. So these are the cumulative amounts, and in this problem we're told that the budget limit is how much?
I think 5 million per year.
5 million. Okay, so that means that we can do C, A, and E because the total cost of those three organizations would be 4.5 million. But we cannot afford to fully fund B or D because that would take us up over the limit. So the answer then is we should fund C, A, and E.
Is this content on the exam?
Yeah, it is. Now, the last part of the question was how many poachers can we expect to arrest if the previous trends continue to hold true into the future? So if we have C, A, and E operating, their past performance was these number of poachers per year. So if we just find the total of those three organizations, so these three organizations, we expect this is how many poachers per year should be arrested if past trends continue. So remember, engineering economy is all about comparing alternatives. And the alternatives that we had in this case was different organizations. They have their own different procedures. They have their own expenses. But they're all producing the same thing. And the thing that they're producing is arrests. So whether it's passport applications being processed, or in this case, illegal poachers being arrested, we assume, in order to compare them, that their effectiveness is just simply the number of things that they're doing. And so then the way that we pick which organization is best is by minimizing the amount of money spent for each one of those things that is being done. So we prioritize the organization that's the most efficient. Organization C, which is Habitat XP, they only have a cost of $2,153 for every poacher that's arrested. Whereas if we went with the Gorilla Watch, it looks like they spend too much time watching gorillas and not enough time arresting poachers, because $36,000 is their average cost per poacher arrested. So they're not at the top of our list in terms of maximizing efficiency. So even if you didn't have time to finalize the procedure, does everybody understand the basic structure of this analysis? Are there any questions before we move on to cost effectiveness analysis? onto economic service life. This is cost effectiveness analysis. The second thing that we're going to do today is service life analysis. So let's move on to that. Service life analysis answers the question, how long should we own things and when should they be replaced? Equipment, sometimes it doesn't just stop working instantaneously, but it may gradually become less useful. And so if you think about the way that equipment may become less useful, is it could be that some equipment is becoming maybe less reliable, like it's breaking down more often, and so there's more days that are being spent on repair, or just it's out of service and so you're not able to produce the thing. Or it could be that you're losing sales. For whatever reason, the performance is being reduced. Another option is that sometimes the market has shifting requirements for what needs to be produced. So it could be, for example, this is showing steel being produced. There are different grades and standards, and sometimes old equipment isn't able to achieve some new requirement. So an example of that is like there are certain aircraft that are certified to fly over the ocean, and certain planes don't have that certification. And so even if a plane can still fly and it's not breaking down, if it doesn't have that certification, which is called ETOPS, then a carrier may find that equipment less valuable and needing to be replaced if they want to open up service to an area that's on the other side of an ocean. Finally, there could be obsolescence. And so here is a picture of a computer that I used when I was in middle school, the Apple II. It had a green and black monitor. The keyboard was built into the CPU, and you can see it had external floppy disks. It didn't even have a hard drive. It was such a basic computer, but this is basically, what I learned to use the computer on. And even if you had one today, if it still worked, it maybe wouldn't be worth holding on to because other computers are so much more effective at word processing or at computing. Like this computer didn't even have a mouse. So it was definitely, it would be obsolete, maybe a museum piece today. So regardless of when we are deciding to replace an item, we can do an analysis that looks at the total cost of ownership for a certain number of years. And when you own something, the cost of ownership comes from what you paid versus what you're going to sell it for. And remember that capital recovery is the annualized difference between the initial purchase price and the final salvage value. So we've talked about capital recovery before. And then there's also the cost of maintenance and operation. So those two things together account for the total cost of ownership. And what we want to do is we want to minimize the total cost of ownership, and we want to see how long, it's just either too cold or too hot in this room. Okay. We want to minimize the total cost of ownership. Now here's a graph that is really important. And speaking of the exam, I think it would be a good idea to be able to sketch something like this and explain it. So what this is showing is that the longer you own something, the capital recovery is going down. I owned a car. It was a Mazda Miata, and I bought it in 2009, and I sold it in 2021. So I had it for, 12 years? I had this car for 12 years, and I bought it for $7,500 and I sold it for $4,500. So I had it a long time, and it didn't cost me much on an annual basis because there was such a long number of years to spread out the cost of ownership over. But towards the end, the annual operating costs were going up because I was having to replace the parts on the suspension. It was breaking down more often. And so what this graph is basically conceptually showing is that as you own something for a long time, The capital recovery cost is going down just because there's a longer period over which you're spreading the initial purchase price, but the annual worth of the annual operating costs is going up. So what you want to do, the economic service life is the number of years that's associated with the minimum cost. So how long should you own something? You should own it for as long as associated with the minimum of those two things added together. So this blue line is the sum of the capital recovery costs plus the annual operating costs. So that's why it starts high, because if you just own a car for 1 year, you're going to have a lot of depreciation. They say that when you drive a car off the lot, it immediately loses 20% of its value. I don't know if that's exactly right, but if you own something for a year, cost of ownership due to capital recovery is very high, even if the maintenance costs are very low. So you want to find that sweet spot of minimum cost, and that's what we're going to do with our economic service life example today, is we're going to choose the number of years that minimizes the total cost. Now, in the analysis of a replacement study, you're basically doing an economic service life analysis for two different options. An option that you already own, which is the Defender, and an option that you're thinking about replacing it with, which is called the Challenger. So if you own a car that's starting to break down and you're thinking about replacing it with a new vehicle, then what you'd do is you'd prepare an economic service life figure for both of them, and you'd find out what's cheapest. Is it cheapest to own your car for 1 more year? Is it cheapest to switch to the new car and keep that for 7 or 8 or 9 years? So a replacement study would just do the economic service life analysis for two different alternatives. And when you're doing that analysis, the market value is the current value of the item that you already own. So if you're going to turn it into like a trade-in or sell it on the open market, the market value is the current value of the equipment, and you consider that as the first cost of the Defender, because if you keep the Defender, what you're losing is the opportunity to sell it. So the opportunity cost of selling the existing equipment that you already own is what we consider as the first cost of the Defender. The first cost of the Challenger is usually just, it's given directly. It's what it would, you'd get a quote from a car dealer on how much it costs to get the new vehicle. So the economic service life is how long you should own the item based on minimizing the total cost, which includes, remember, capital recovery and annual worth of the annual operating costs. So the first cost of the Defender is the market value. The first cost of the Challenger is its purchase price. And the sunk cost, how much you've spent on a piece of equipment in the past, may be completely unrelated to its market value. So for example, if you drive a used car and you just put tires on it, and you just got the brakes done, and you flushed the radiator, and you waxed it, and you vacuumed it, all of those things may have some small indirect influence on its market value. But if you told someone that you're selling the car to that you just put new brakes on it, they're going to say, well, cars are supposed to have brakes. I don't necessarily care that it's got new brakes. And so there's not a direct relationship between all of your previous expenses and the market value. It's only an indirect relationship. So you don't include your previous expenditures in a replacement study. Okay, so here's the setup of the second example we're going to work today. Let's say that we're buying equipment that was $20,000, and what we know is that if we, we're buying it for $20,000 at time 0. And at the end of the first year, if we sell it, we can get $10,000. If we keep it for 2 years and then sell it, it has a market value of $8,000. So this column, I think, is obvious. If we hold on to it for 5 years, then it has no salvage value. What we see for the equipment is that the operating costs are going up over time as the equipment becomes a little bit more frail and troublesome. Then the operating costs are increasing. So we want to know, if we've got a 10% interest rate that applies, how many years should we keep the equipment? Now there's a template file that I've put on Blackboard. So if you go to Blackboard, you're going to find an Excel file that I just loaded there today. And download that because we're going to use it for the in-class exercise today. So go to Blackboard, our course page, and it's at the bottom. This template, Economic Service Life Analysis. So download it and open it. We're going to go through this together. Okay, so the data is already in here that has the market value and the operating costs. Does everybody have the template open? Anybody need a little more time to get it downloaded and open? Okay. So it's on the back side of the paper that I gave you earlier, is the details of this one. So the interest rate is 10%, so put in 0.1. The first cost, you can see from the template, it says here, it's a reminder that the cost should be negative. This equipment, when we bought it, was $20,000, so put in minus $20,000. That's our first cost for the equipment. Okay. Now, we're first going to look at the operating costs in columns D and E. And then column F is related to capital recovery. So capital recovery is going to take into account the first cost and the market value, whereas columns D and E are all just related to this operating cost data. Now, the $5,000 in operating costs at the end of year one, what we need to do is we need to find out what's the value of that at time 0. Because this 5,000 is at the end of the first year. We want to know what's the present value, meaning what's the value of that at time 0. So we're going to do equals PV and refer to the interest rate of 10%. So we can just click on that cell that has the 10% interest rate. And maybe I'll anchor that reference so that when I'm dragging the equation down, it always looks at the same spot. Okay, NPER, number of periods. Okay, so we're on row 1. What we want to do is we want to move that $5,000 to time 0 because we want to know the present value of the operating costs in this year. I'm sorry, NPER. So this is one. Skip over the payment field, and then the future value is just going to be the negative of this. Okay. So $5,000 at the end of the first year is the same as $4,545 if we move it to time 0. So that's simple, right? Everybody remembers the PV function? Okay, but there's a word in here that should be catching your attention. Cumulative. Cumulative. Okay, so if we go with 1 year of ownership, our operating costs are just this $5,000. But if we are owning it for 2 years, then our cumulative operating costs would be the operating costs of the $5,000 at year 1 and $6,500 at year 2. So what it says here is that we should use the NPV function because we want it to be all of the data in a row for whatever line we're on. So equals NPV, the rate 10%, and then the values are just going to be these first two. Okay.
Can you also just do the PV and sum it to the last one?
Let's try.
Well, that's what I did, and I got the same.
Okay, so you're saying use the rate, and then NPER is 2, this is our amount, and then we also want to add it plus the one above, right? Yep. So 9917 or NPV at 10%, and we want it to be these two expenses taken to times 0. So we're taking however long we own this equipment. If we own it for 3 years, now we got to do NPV where it's 10%, and then it's these 3. Now, why have I not just dragged it down from here? Well, it's because we're selecting a range. And you can if you have an anchor on the first one in the range. So I'm anchoring C8. Now I think I can drag it down the rest of the way. And, oh, maybe not. I didn't anchor the interest rate. Now I can drag it down. So for the last one, for example, it's looking at the interest rate of 10%, and then it's taking all of these individual annual operating costs and taking them all to times 0. Any questions, Jace? Huma? Do you understand it? Okay.
I didn't write it down, I just did the NPV for everything.
Yeah. Did it repeatedly?
Mm-hmm.
Okay. Okay, so column E. So now, column E, the instructions that's given here is do the payment function of column D. So remember, what is the PMT function? That is the function that calculates an annual amount. So for the first one, it's going to be silly because we're just going to end up with the 5,000 that we started with. But for the other ones, what it will do is it'll tell us how much it would cost to own them if we were paying the same amount every year for the operating costs rather than if we were paying a different amount every year. Because what column E is basically saying is, what if you know these are going to be the operating expenses, but you don't want to have a different amount every year? You just want to pay the same amount every year. What should that amount be? That's what we're going to calculate in column E. So it's going to be equals PMT, refer to the 10% interest rate. The NPER is going to be whatever year we're on. And then what we put into the PV is the minus of the amount in column D. Okay, so basically, if we're just going to pay 1 year of operating expenses, then it should be 5,000. That's the annual worth of the present value of the cumulative operating costs to date. But then if you drag it down, what we'll get here is, on an annual basis, the cost of operations and maintenance. So, for example, for year 5, what we're saying is you need to pay $7,961 every year for the operating costs so that you don't have a different amount every year. So this is economically equivalent to paying $5,000 in year 1, $6,500 in year 2, $8,000 in year 3. Instead of doing that where the amount is just constantly changing, this would say you always pay $79.61 every year and you'll have enough to cover the operating expenses. So some years it's a little more, some years it's a little less than it would have been if you just paid the amount that was due. But this is just kind of evening things out. The electric company kind of does that for people sometimes. They have, because people don't like paying a huge amount in the summer when their air conditioning is running, the electric company will allow you pay kind of like an even rate through the year, because they'll have you pay a little bit more than you would ordinarily in the winter and a little bit less than you would ordinarily in the summer to kind of just even the payments out. So this is a similar idea in column E, as we're calculating the annual worth of the PV. All right, now capital recovery. Do you remember how to do capital recovery? Remember, capital recovery, if I was going to do a sketch of it, if I was going to say, like on an exam, sketch a capital recovery, what you've got is at time 0, a first cost, and then some years in the future, here's the salvage value. So P and F, and you're selling the item after a certain number of years, like maybe after 5 years. And so you want to find out what's the equivalent annual amount. 1, 2, 3, 4. This is our 5th year. If you're going to find out what's the equivalent annual amount, instead of paying one big lump sum at time 0 and getting a small disbursement at the end of the service, how much would it be if you were just going to pay an amount every year? That's the capital recovery. And we can calculate it by putting both the first cost and the market value into the PMT function. So equals PMT, refer to our interest rate, NPR is the number of years, the present value is the first cost, and we need to anchor the reference to that because that's always going to be the same. And then for the future value, that is the market value. And I don't recall whether we need to put the minus sign in this. Let's just see what we get. I do, because the capital recovery should also be an outflow. So we need the minus sign for both the PV and the FV. Yeah. Okay, and then dragging that down will tell me the capital recovery, like if you have it for 5 years, then you're spreading out the $20,000 purchase over 5 years of ownership. And even though there's no salvage value at the end of 5 years, the capital recovery is just lower because you are able to operate the equipment for more time. The last part, the total annual worth of costs. So here you can see that column G is the annual worth of the present value of cumulative operating costs to date plus the capital recovery. So if you own this equipment for just 1 year, then the total cost would be $17,000. That's taking into account the operating costs and the capital recovery. If you own it for 2 years, $13,429. So what we want to do is find out how many years should we own this equipment. What's the optimal number of years to keep it? 3 years is best. Economic service life. The equipment itself could be kept for 5 years, like its physical service life, like it's not worn out after 3 years, but economically its service life is 3 years because if you own it longer than that, then it's more expensive. It's better to sell it while it still has some salvage value, and it's better to avoid these increasing operating costs. So like if you sell it in 3 years, what's the advantage of that? It still has a little bit of value, and you're avoiding these increasing operating costs. And you can see that the total costs are minimized if we consider both capital recovery and the operating costs for 3 years of operation. So any questions about that?
Can you open up column E again?
Yeah. So we're taking column D as a lump sum at the present, and we're spreading it back out over how many years it's being operated. So let me do a sketch that illustrates this, because this is important. Let's look at 5 years, because I think 5 years is maybe going to be the best illustration. Okay, so we're just looking at the operating costs. 0, 1, 2, operating costs, it's 5,000, 6,500, 8,000, 9,500, and 12,500. Okay, so this is what we've got here is column C. Annual cost data. All right, so if we convert that to a single lump sum, that is column D. So basically, this column D. So you take all these amounts to just a single lump sum, then that's column D. And then column E is, let's find out for that lump sum, what is the equal amount every year. So 1, 2, 3, 4, 5. So we found that the lump sum was 30,178. And so we've got 30,178, and we want to find out what is the equivalent annual amount. So it is 7,961. So A equals 7,961. So the idea is, if you were operating a business, it would be really challenging to have your operating costs going up every year like that. So what you'd want to do is you'd want to know, instead of having variable operating costs, how much do I have to just count on spending the same amount every year? So you'd say, well, I'm going to take these variable operating costs to the present, and then from the present, spread it out as an annual series. How much is that annual series? And so that's what we've done here in column E, is for each number of years, what would be the operating costs on an equal annual amount? Any other questions? You guys don't have the enthusiasm for this stuff that I was hoping you would. I'm just getting a lot of kind of like hungover looks or tired. Looks like maybe you're ready for the end of the semester.
6 more weeks.
Yeah? Is that many? I'm surprised it's that many.
No, it's like.
Is it really? Is it really?
Our final exam's on the 24th, I looked at it today.
24th of April?
Yeah.
Are you serious?
Yeah.
Wow.
24 or 25th?
Dr. White?
Yeah, I think it's 25th.
Tuesday.
So we've got the week that we're in, plus 1 more, 2 more, 3 more, 4 more. Yeah, April 25th, final exam. Huma, do you have a question?
Yeah.
Okay.
Not the question actually. I didn't get the. When I drag it down, I just don't get the values. Did I do anything wrong here? Are you
Let's see.
Anchor.
So this one's the rate.
Mm.
This one's the present value.
It's negative PV, so negative first cost.
It was good. The one thing that you need to do is you need to anchor the reference to the purple one. So it should always be the same first cost. So put the dollar signs here, and also put the dollar sign. Oh, you already have it for the interest rate, but you need to put it for the first cost as well. Okay, well, that's all I have for you today. I can stick around if you've got questions on the in-class exercise or anything else. But just to wrap up, let's take one last look at these announcements. That we've got an exam on Thursday. Maybe have a cup of coffee before you come for the exam. You're also morose, low energy. Question, Ben?
No, I think I'm good. I
All
got
right.
it. I don't know, that week off, and like a normal life again.
Yeah.
I should have never quit school, I should have just came straight to.
No, you'll get through it. You'll get through it.
Taste of, you know, back to normal, and I don't.
Only having 2 responsibilities instead of 3?
Yeah, it was more like only having 5 responsibilities instead of 6, but.
Yeah. All right. You'll get back into this swing.